the neat things about derivatives is that the derivative of a function is a function. What does that mean? Well, that means that oftentimes, not always, that the function that it generates is also a differentiable function, which means that we can, once we have a function and we take its derivative, we can then take the derivative of this function and so on and so forth. A really good example of that is in studying classical physics. If you have some sort of position function, then its velocity is described as the instantaneous rate of change of the position. How is the position changing at that time? And that's your velocity, because as you move, you're moving the position. So that's represented as the first derivative of the position function. The acceleration is talking about how the velocity is changing. So they call it an accelerator in a car because pressing that changes the speed at which you travel. So since it changes the speed, it makes sense to think of it as the derivative of the velocity. But since the velocity is already a derivative itself, it is actually what we might call the second derivative of the position function. So in general, to find a second derivative, you take a derivative of the first derivative. And an example would be like this. If position was t to the fourth, well then the velocity, which is the first derivative, is 4t cubed. Well, then to get the acceleration, we take the derivative again, and so by the power rule, we bring down the 3, multiply it, we get 12t squared. And that's how we do that. Now, there's a lot of conventions on how multi-derivative notation, but so we're just going to kind of go over some. And guess what? There's even more than this, which is awful, but it's just true. So if I have some function y, I might call the first derivative y prime. The second I might call y double prime. The third I might call y triple prime. But then once you get into the fourth derivative and so on, you don't really use those apostrophe, that prime style notation anymore. You just start putting the derivative number in parentheses. So you see the superscript parentheses, a 4, and then if you do some arbitrary, nth is like arbitrary, it could actually be 2, it could be 200. You just put y to the n, or y, apostrophe n, and that tells you that that's the arbitrary nth derivative. But y also has this dy dx. But if we do the second derivative, we say d2y dx squared. So notice the 2 comes after the d here, but it comes after the x on the bottom. So d2y dx squared. d3y dx cubed, d4y dx the fourth, or dn the y dxn. Notice in this particular case, the notation changes really from here to here because you don't have a 1, but after here it doesn't change. After here, this one changes. So again, this is all common notation because people don't want to be writing a bunch of apostrophes. So in this case, dxy, dx2y, and so on and so forth. With the F notation, I like the F notation. The F notation looks a lot like the Y notation. You have F prime of X, F double prime of X, F triple prime, F4X. Whoever you talk to says it differently, but generally speaking, you just say the fourth derivative of X, the nth derivative, fourth derivative of F, nth derivative of F. And then you have this ddx, d2 dx squared, d3 dx cubed. Notice that these notations are similar, just like these notations are similar. And this one's kind of the black sheep here. So there are a lot of ways that these can be expressed, but this is a notation thing. Don't worry about this as much. What you need to worry about is this. The idea is when you take a higher order derivative, all you're really doing is taking the derivative in succession. So once you get the first derivative, take it again and again and again as you need to, up to how many times or how many derivatives you need.